In this video, we will look at the basics of solving a linear equation that involves only one or two steps. So before we do that, we need to know what it means to solve an equation. And really, it just means you're isolating for the variable so that you can figure out what value will make the equation true, meaning when you plug that value in for the variable, the left side is equal to the right side. So that way the statement is true. Now, when we're solving linear equations, we use opposite operations. So let's just quickly recap what those opposite operations are. The opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division. And likewise, the opposite of division is multiplication. When you have an exponent of 2 and you want to get rid of it, so think back to Pythagorean theorem from grade 9. The opposite of an exponent of 2 is to square root, and then likewise, the opposite of a square root is an exponent of 2. Now, we're going to start off with one-step equations. You'll notice in these 4 little examples that we have, we're just trying to isolate for our variable, and there's only one number in our way, and we're going to get rid of it using the opposite operation. So in the first one, I have x plus 5. I have addition of 5. The opposite of addition is subtraction. So to move this to the other side, I'm really just subtracting 5 from each side. Now, the way you show this is really up to you. You can show the subtracting 5 from both sides, or what I personally like to do, I show that I'm bringing the 5 to the other side, and when it moves to the other side, the sign changes. And that way we deal with that opposite operation idea. And 7 minus 5 is 2. Now, what's really nice about linear equations is that after you do an equation and you solve for it, you can check and see if you got 100% on it by doing a left side, right side check. So you'll notice I've already set them up. But really, all you're doing is creating this little T-chart. You're going to put the left side and the right side on top. And what the left side and right side is the left side of the equal sign. Okay, so here's my equal sign. On the left, I have x plus 5. And on the right side, I have 7. Wherever I see the variable, I'm going to replace x with the 2 that I just got. So instead of x plus 5, I'm going to write 2 plus 5. And now you just simplify. 2 plus 5 is 7. And now, if I look at the left side and the right side, they match. So I know I did this correctly. If I look at my next example, I have negative 12 plus s. I need to isolate for this s, but the negative 12 is in my way. So the negative implies subtraction. When I bring it to the other side or use the opposite operation, that subtraction will turn into addition. So again, you can either show it by adding 12 to both sides, or we can just show it as I write the negative 8, and when I bring the negative 12 to the other side, it becomes positive 12. I personally like to show it in this second method because that will make it easier as the equations get more complicated. And now you can go to your calculator or do this in your head. Negative 8 plus 12 is positive 4. And now, let's do a little left side, right side check. So on the left side of this equal sign, I have negative 12 plus s. On the right side, I have negative 8. I can't do anything with the negative 8, but on the left side, I can replace s with positive 4. And negative 12 plus 4 is negative 8. These are matching, so I am confident I did this perfectly. The only place I could mess up potentially is my communication, but notice for communication, I just have my equal sign down the middle. There are not 2 equal signs per line, and I'm showing my work. Now, when I go to number 3, I see that I have 3x equals 12. The 3 and the x are attached by multiplication. The opposite of multiplication is division. So I'm going to divide 3x by 3, but whatever I do to one side, I have to do to the other. I have to balance it. So 3 divided by 3 is 1, which is perfect. Now I'm just left with x. And then 12 divided by 3 is 4. Let's check. The left side is 3x, the right side is 12. If I replace x with the 4 that I just got, 3 times 4 is 12. They match, perfect. Now in these one-step equations, it might be silly that I'm doing a left side, right side check, but I just want to show you how to do it. And you know, you don't have to show it the way I'm doing it. You can just do it in your calculator. And the whole point of this is try it in your calculator, and that way you can see if you're right or not, and you can catch some potential mistakes. Now our last one-step equation is m over 5 equals 3. Remember, fractions are just division. So I'm doing m divided by 5. The opposite of division is multiplication. So if I want to get rid of the 5, I'm just going to multiply both sides by 5. That way, when I do the over 5, the division of 5 with the multiplication of 5, they cancel out, and I'm just left with the m. And when I do 3 times 5, I get 15. Now let's check. The left side was m over 5, the right side was 3. We got 15 for m, and 15 divided by 5 is 3, so perfect. I'm happy. And again, if I didn't show my check, I could have just gone to my calculator and did 15 divided by 5. I got 3, which matched the right side, so that's great. All right, let's move on from the one step. We are going to apply these ideas of opposite operations, but this time it will take us 2 steps. Now, if we look at our next few examples here, you will notice that you have a term that's either being added or subtracted to the variable, but also in front of the variable, there's a number attached by either multiplication or division. When you are solving a linear equation in this setup, you always get rid of the addition subtraction first, and then you deal with the multiplication and division at the end. So really, this is the opposite of BEDMAS, because when you're simplifying an expression normally, no variables involved, you do the brackets, you do the exponents, you do the division, multiplication, then addition and subtraction is at the end. But when you're solving, you're actually doing the exact opposite. So I personally don't think of it in terms of the opposite of BEDMAS. I think of it more as whatever is furthest from the x, I get rid of it first. Whatever is kind of attached to the x, that's the last thing that I'm going to get rid of. So if I look at 4x plus 3 equals 23, the plus 3 is further from the x. It's the thing attached by addition, so that's going to go first. So I want to move it to the other side. So when I move something over the equal sign, the sign changes. So I have 4x, because the 4 hasn't disappeared, equals 23 minus 3. 23 minus 3 is 20. And now, there's one step. We have one more step left. 4 is attached to x by multiplication. The opposite of multiplication is division. So the 4's cancel out, and then 20 divided by 4 is 5. And there's our answer. Now let's check it. The left side is 4x plus 3. The right side is 23. So nothing to do on the right side, but on the left side I have 4 times 5 for the 4x and plus 3. Now you can do this all at once in your calculator. I'm just going to go a little bit longer here and do some simplifying. So 4 times 5 is 20, and 20 plus 3 is 23. They're matching. I know my answer was correct. So if you have time to do the check, why not do it? All right, number 6, 7x minus 9 equals 53. So again, the constant goes first. So I have negative 9 here. When I move it to the other side, that negative will become positive. So 54, the negative 9 crosses the equal sign, so the sign changes. 54 plus 9 is 63. And now, final step, I need to get rid of that 7 that's attached by multiplication. Opposite of multiplication is division. So I divide both sides by 7 because it's the 7 I'm trying to get rid of. So now, 63 divided by 7 is 9. Let's check. 7x minus 9 is on the left side of the equal sign. 54 is on the right. So 7, instead of the x, I'm going to put the 9 that I just got. 7 times 9 is 63. And 63 subtracted by 9 is 54. And you can skip that middle step. You could just go to your calculator and write it in right away. All right, next one. It's a little different because I have the x over 2, but then I do have plus 1 equals 7. So the plus 1, we have to get rid of it first. When I bring the positive 1 over, it becomes negative. So 7 minus 1 is 6. And now the 2 is attached to the x by division, so I have to do the opposite of division, which is multiplication. So I'm going to multiply both sides by 2. So now I just have x on the left because my goal was to isolate for it. And then 6 times 2 is 12. Now for my left side, right side check, just to make it a little quicker, I'm not going to write the original x over 2 plus 1. I'm just going to put 12 in right away. So 12 over 2 plus 1. So that's 6 plus 1, which is 7. And on my right side, I have a 7. So yay, this is correct. All right, the next one, I have 5 minus x equals 3. You need to be very careful with your signs here. Notice the x isn't in front. So I need to get rid of the 5 because the 5 is the constant. When I bring the 5 over, it's going to turn into a negative 5. What we're left with though is not x. We're left with the negative x because there was a negative 1 in front. If you want, I recommend you write it as negative 1 so that you see that there is something you have to get rid of. Our goal is to isolate for positive x, not negative x. So I do have to take an additional step of dividing out the negative 1 when I'm ready. So 3 minus 5 is negative 2. And now let's divide both sides by negative 1. I'm not dividing by negative, I'm dividing by negative 1. Because remember, if you don't see a number in front of your variable, it is just implied to be a 1 or a negative 1 in this case. And now negative 2 divided by negative 1 does become positive 2. Remember, 2 negatives make a positive. Now for my check, 5 subtract x, which is 2. That gives me 3. And guess what? My right side is 3 as well. All right. Why don't you pause the video here and try number 9 on your own. Be careful with that negative in front of the 2. And once you're ready, come back to the video and check your work. All right, so we're going to bring the 5 over first. You are left with negative 2x on the left. The 5 moves over, it becomes negative. So that's 12. We're not dividing out 2, we're dividing out negative 2. That way the negatives cancel out, and you are left with x. And then 12 divided by negative 2 is negative 6. Be super careful with your signs here. If you mess up on your signs, your left side, right side check will not work. So for the left side, we will have 5 subtract negative 6. Negative 2 times negative 6 is positive 12, so that's 17. And our right side is 17 as well. And again, you could have gone straight from this step to 17 by going to your calculator. All right, our last one here. So again, pause the video, try it on your own, and then come back to check your work. So we will bring the 3 over first. The 3 will turn negative, so that we have negative 21. I need to get rid of the 3. Don't get in that trap where you're always dividing out at the end. In this scenario, we have division, so I need to multiply both sides by 3 to do the opposite operation. And we do end up with negative 63 for x. And let's try it. The left side, 3 plus x, so negative 63 all over 3. And negative 63 divided by 3 is negative 21. So we have 3 plus negative 21, which is negative 18, which is exactly what our right side is. So there we are. So once again, get rid of the constant over, bring it to the other side using the opposite operation, and then get rid of whatever's attached to the x by either dividing out the coefficient or multiplying by the denominator, depending on what you have. And use a left side, right side check. It's a nice tool to see if you did it correctly and potentially catch a mistake.